Good morning, guys. Let's start the second part of the Cannizzaro's reaction, children. The basic thing which we learned, it's a disproportionation reaction. One aldehyde undergoes oxidation, the other one undergoes reduction. And that to be, there is a conditional oxidation and reduction where there is no alpha hydrogens, here. Okay. Now, let's see the mechanism part, children. Just I am taking one of the aromatic aldehyde, that's benzaldehyde. When first of all it reacts with base at 50% means low concentration. Then base attacks the carbonyl carbon. Then it's going to be a nucleophilic addition reaction. Then it attacks, it gives rise to by shifting a bond that hydrated anion is obtained here. Hydrated anion, that's or else you can say hydrate anion. So this hydrate anion, again in presence of whatever is called here base, that base is going to be what's called here, it's going to be absorb the proton from OH group, and that's going to give us what's called here tetrahedral dianion. I am repeating, children, once again, listen cautiously. First of all, the OH minus interacts with the carbonyl carbon, undergoes nucleophilic addition, and after that you are getting hydrated anion, and after that the base once again interacts and it's going to be deprotonate H plus ion from OH group. Now at this juncture we are getting tetrahedral dianion. Remember this term, children. Remember this term, tetrahedral dianion. When you have chosen this tetrahedral dianion, now this entire is called step 1. This is called step 1. After getting tetrahedral anion, there is one more friend, that is another molecule of benzaldehyde. That won't never keep quiet in presence of base. What the base is going to do here? The job done by base again. Here, it's going to shift the hydride ion to the carbonyl carbon. Again, it's a nucleophilic addition. So that it's going to get us what's called here, what's nothing but known as here, it's benzoxide ion, benzyl oxide ion, or you can say alkoxide ion, substituted alkoxide ion. So that what is happening here means now, at this, whatever is called here, the entire process, one is carboxylate, then another one is alkoxide. This is called step 2 mechanism. Once again I am repeating, children, listen cautiously. Toughest question, of course, may or may not be in the NEET part. In general, a few questions focused in mains part. That's why I am just giving you this hint also. Which one is going to give the hydride shift? That's what we are doing. The first molecule reacts with base, and that gives rise to hydrated anion. And again in presence of base, deprotonation occurs. That gives rise to tetrahedral dianion. And in this tetrahedral dianion is going to play a key role that makes to shift hydride ion. That hydride ion shift also activated by base, that's going to give us, it shifts what's known as here hydride. It's going to shift hydride. Now it's going to give us alkoxide or benzyl alkoxide, and also you are getting carboxylate, benzoate anion after hydride shift. This is called step 2. This is the RDS, rate determining step. At this level, children, these two formation is nothing but step 2. Coming to the step 3 is concerned. What's happening here means, in presence of water in presence of, or hydronium ions are there. So then, first water interacts with benzyl alkoxide ion, gives rise to benzyl alcohol, and benzoic acid is also formed, but for just our sake we are going to have sodium benzoate. Here you listen carefully. Water converts this into like this, water molecule. Hydronium ion converts this into benzoic acid. That also there, but I am not writing here. These are the 3 steps, children, in presence of base. What is happening means this is absolutely based on the mechanism regarding the benzaldehyde is concerned, which is not having alpha hydrogens. I think you have followed me, children. So these are the entirely 3-step mechanism which is going to give us Cannizzaro's disproportionation reaction. Next, order of donating. Such a beautiful, tough question, children. It's mains as well as may be expected. The question will be as it is like this. Such a simple question is concerned. Which has greater tendency to donate hydride ion? Which has greater tendency to donate hydride ion? Generally, see, I have taken only para substituted here. The para substituted amino group, I mean para amino, whatever is called here, benzoate, para methoxybenzoate, para nitrobenzoate, which I have taken, children, here. These are the 3 tetrahedral units which I have taken. This causes plus M effect, plus R effect, or plus R effect. It's plus M, plus R, and minus I also there little with this. And this is going to cause minus I effect, and of course minus R also. What I am doing with respect to these are all going to be undergoing resonance. This is going to be activate the ring and makes to donate hydride ion very rapidly, because its plus M effect greater than methoxy group, and H2 plus M effect is greater than this, and that's why it's the best hydride donor. It's going to be the best hydride donor. The second one, generally plus M plus R effect is directly proportional to hydride donating capacity. Hydride donating capacity greater than paramethoxybenzoate, greater than para-nitrobenzoate, because it is having minus I effect or minus R effect, or you can say minus M effect also. 100% question here. If this wants to eliminate many people, the intermediate is tetradianion is the commonest question, but everybody will ask. At that stage, the hydride shift is plays key role. So children here, which is going to be the best hydride donor? Where there is a plus M effect or plus R effect, that they are going to have greater tendency of donating hydride. So that this is the order of hydride donating capacity. Electron withdrawing groups are going to be having what's called their least tendency to donate hydride. Next of that reaction, last but one. These are all high standard, but let me just what my inner soul loved ups, just let me teach this. The kinetics of the reaction is, rate is directly proportional to 2 aldehydic concentration and 1 hydroxide concentration. Total order, common order is going to be 3rd order reaction. But when concentration is high, it depends upon 2 aldehydic molecules and also base twice. Hence, order is 4th order reaction. At high concentration, this is at low concentration, at high concentration, children. And one more, last but not least question, once again I am repeating. The order of tendency of donating hydride ion based on plus M and also minus M minus R effects. So that I have given in a very simple, sweet manner. Of course, though it is not in our purview, we are doing this because one of the expected corner, if the paper is tougher to eliminate majority in India, those who are appearing for NEET. And coming to kinetics, the rate of the reaction is based, it's nothing but based on twice of aldehydic concentration and 1 of this one base. That's why it's overall at low concentration 3rd order reaction. At high concentration, it's going to be based on twice of aldehyde and twice of base. At high concentration, it's a 4th order reaction, children, so that you can go for it. In general, the Cannizzaro reactions are going to be third order reactions. And last one, children, what I am doing is going to be stability of dianion, which is going to be the most stable dianion in the given 3 molecules. What I have given here, no? 1, 2, 3. The stability of dianion. Stability of dianion. So that's directly proportional to minus I. Minus or Fx. Minus I or minus I Fx. So the most stable dianion is nothing but the most stable dianion in the given, children. Here I have given, no, that's going to be, which is having electron withdrawing groups, like which I have given this one. It's nothing but what is, say, nitro group, and what's known as here OH, O minus and H. This is most stable dianion. Thank you one and all. Thank you, children. Let's move to the another part. Of course, we have done a bit depth. Don't ignore this, children. This is a beautiful objective you can expect if the mechanism is focused more. This is also another one. I have shown in 3 steps and one more, tougher angle of Cannizzaro. So I'll do at the time of advanced part. Thank you, children. Thank you.